Okay, so start recording already. Nine people here already. 9 orang. 9 orang. Let me see, 9 orang. Any more or not? Any more? 9 should have 12. Never mind, we wait a short while. 2 more minutes, because today we have 2 sessions, very long time. So it doesn't matter. Right. Okay, never mind. I just refresh your memory, right? Now, last week we learned about this radian. Now, radian is just another unit for measuring angle. Just like kilogram and pound, they are two different units measuring the same physical quantity. Okay, so now we come back to radian. Radian and degree, they are two units, two different units used for measuring angle. So you can convert from degree to radian, radian back to degree using this factor pi divided by 180. Okay, so if you convert from degree to radian, then you multiply by pi over 180. If you want to convert from radian to degree, then you multiply by 180 over pi. Okay. So next, we also learn how to convert using the buttons, right? The buttons. And I told you if it is more than 30 seconds, you have to round off to 1 minute, like this. Like this, 45, more than 36, sorry. So it's more than 30, you have to increase 1 minute. Okay. Now, the next thing is I ask you to remember this table, memorize the value. Now, especially 90 degrees is pi over 2 radian, 270 degrees, oh no, sorry, 180 is pi radian, 360 is 2 pi radian. Now, these special angles, their conversion you have to remember, right? Why is it so? Why is it so, right? Okay, how many here? Okay, everybody here except one maybe, except one. Okay, right. So now, why do we want to learn radian? Why should we want to learn radian? Now, the reason is we want to find the arc length and the area of a sector. Now, using radian, if you want to find the arc length and the area of a sector, it will be very much easier. Now, because you look at here, this formula. Now, the arc length is r multiplied by theta, that's all, right? So, what is s? S is the arc length, so this is the arc length, right? This green line here is the arc length. So this green line is the arc length. And if you want to find the length of this line, green color line, then you need to use the radius multiplied with the angle. So you use this radius, the length of the radius, multiply with the angle. But this angle, you must change it to radian. If the angle is given to you in degree, then you have to change to radian. Right? So that's all. Right? So the arc length is the radius multiplied with the angle in radian. Now we find, if you look at the formula here, and you realize that there are how many variables there? There are together 3 variables, r, s, r, and theta. So if in this equation, an equation has 3 variables, if you are given any 2 variables, you can find the third one. For example, we look at this one. Right, you want to find this green line here. The first example, look at the first example. You are given the r and the theta. Can find or not? Can. Now look at the second example here. This green line is given. The angle is also given. Now you want to find the radius. Can or not? Can. So as long as you are given 2 variables, you can find the third variable. So if you look at this last example here, we are given the radius and the arc length. What do you think they want us to find? Surely they ask us to find the angle. So you need to find the angle, right? You need to find the angle. So we're going to continue here. Now, if you look at this problem here, they ask you to find the arc length FG. So once you read the question and it has anything to do with the arc length, you quote the formula. So what is the formula that you need to quote? S equals to R theta. Quote the formula means you copy down the formula. You look at the formula in front of the question paper. So in your SPM, the question paper is a booklet. So the first page, you see this formula there. So you copy down this formula and fill up with numbers. So I copy down this formula, S equal to R theta. Looking at this diagram, what is S? S is FG. S is FG. So I replace the S with FG. Then I see R theta. So R is what? I look at the diagram here. R is 10. So I put down 10. Then theta is what? Theta is 25:19. Can I put down 25 degrees 19 minutes? Cannot. Because the formula, if you want to use this formula, the angle has to be in radian, but your angle is given in degree. So what must you do? So you take this angle, you multiply by pi over 180. Now in this way, you will convert the angle to radian. You will convert the angle to radian, and you just continue to multiply, right? You will get the answer 4.419. Now, if your answer has all those bubble there, all those not there, try to click on the DMS button. So you will get 4.419. Right? So sometimes the calculator is very stupid. They don't know that your answer is in centimeters, so they also convert into radian for you. So if that is the case, you just press the DMS button, get the number, write it down in your answer here, right? Lin, Zoe Ong, Tan. Okay, then Jian Tong, Ang Yi Fen, Jia Ying, Sarah. Where is the boy? The boy didn't come. Who is the boy? Wei Heng, I think. Is he here? Wei Heng here or not? 2, 4, 6, 2, 4, 5, 11. Wei Heng is not here. Okay, right. So far, any question or not? Any question on this? Anyone? This one? No question. No question. Then we continue with the second problem. Now, in this second problem, you are given the arc length, you are given the angle. Now, given the arc length and angle, what they want you to find? There are only three things: arc length, angle, the third one is the radius. So they ask you to find the radius. So again, you quote the formula S equals to R theta. So you get S equal to R theta, then you look at the diagram, look for S. So S is 25. Now what is the radius R? Don't know. Then you just leave it as R. Then look at the angle there, 2.1 radian. You see the word radian there? So you just put inside here. No need to multiply with pi over 180 because the angle is already in radian. So if it is not in radian, you convert into radian. If it is already in radian, no need to do anything. Just write down 2.1. Solving this equation, you have the radius is 11.9. So you see that what I'm trying to show you is that the question, the formula has three variables. They give you either one of these variable, right? ask you to find either one of these. If they ask you to find this, they must give you these two. If they ask you to find this, they must give you these two. And if they ask you to find this one, they must ask you to give you these two. So I'm showing you the different examples, right? Last example here, last example, given the arc length is this one, 25. This arc length here. Arc length is 25, radius is 15. Find the angle in degree and minute. That means they want you to find this angle here, the angle at D here. Okay, now understand the question, huh? So click here. Again, you use this formula, S equals to R theta, right? S equals to R theta. What is S? Look here, S is 25. You just put down 25. What is R? R is 15. You write down 15 here. Then theta is what you want to find. So you leave the theta as an unknown. Solving this equation, you have theta equals to 25 over 15 or 5 over 3 radian. Now why I write down radian here? Because in this formula, the theta is radian. So in this formula, the theta is in radian. So your answer is in radian, right? So don't think that, oh, this is 5 over 3 degrees. No, it's not 5 over 3 degrees. It is 5 over 3 radian. But the question say, find the angle in degree and minute. So this angle here, you have to convert to degree and minute. How to convert? You look back here, convert, you multiply by 180 divided by pi. Okay, 180 divided by pi. So the radian multiplied by 180 divided by pi, you have the answer in degree. Now this degree is in decimal place. If you want degree and minute, you have to press the DMS button. So the DMS button, you get 29.34, 34.6 minute second. So this is more than 30. The last division. The last division is more than 30. So you have to carry 1. So becomes 95, 30. Okay. Any question?
Teacher,
Yes.
teacher,
Yes.
if the question didn't just call us to find the angle EFT, they didn't call us to find in degree and minute, we must write in what answer?
If it is not asked, then you can leave the answer in radian or in degree. You can leave in either one. But normally in the exam, they will if the answer is in radian, they will ask you for degree. If it is in degree, your answer is in degree, they won't ask you for radian. But probably in the following part, that means the question there, the following part, you have to make use of the angle in radian. So if you find the answer, if it is in degree, be ready to change it to radian. Now, if your answer is in radian, probably they want you to do in degree, right? But if they didn't say anything, you just say, oh, 5 over 3 radian is acceptable. But the following part, they may ask you to change, right? Then you have to be careful. You have read the question carefully. Any other question? Any other question? This one. Ang Liwen, any question? No. Xia Ying? No. God. Ang Liwen said no. Joey, can I follow or not, Joey? Joey. Chen Tong, can or not, Chen Tong? Sarah and Tong, okay, Sarah also okay. Zini, Sini, Xingyi, Sini can, Yin, Xini, Yifen, and Jia Yan. Last one, boy, can or not? Kai what? I cannot remember. Kai something. Boy, can or not boy? Can't remember. Kai what? Yeah, can. Okay. So can, then you have to do this homework here. Huh? This homework here. This homework. Okay. So you have to do the homework. Page 7 as what is this? Self exercise 1.2. So you do inside the exercise book. Your teacher probably will ask you to do. So you do inside exercise book. And if you cannot, then you ask me. Wednesday, I show you how to do. Okay. This is the inside the exercise book. Okay, close this. Right. Okay. Now we move on to the next one. Now, other than finding the arc length, you have to know how to find the perimeter of a segment. Now, before we find the perimeter of a segment, I would like to explain to you what is the meaning of a segment. A segment inside a circle, it is not a segment of a line. Segment of the line means there is a straight line, then you put one dot here, you put another dot here. So the distance between these two dots is the segment of a line. But in a circle, the segment is different. So we look at the screen. I explain to you what is the meaning of segment in a circle, right? Okay, first one. Now, this segment, the perimeter of a segment consists of two parts. One part is called the chord, and the other part is called the arc length. It's called the arc length. Okay, right. So where is the chord? Where is the arc length? Let me explain. Now you look at this. Sector here. The sector here is bounded by one radius, two radius, and the green line called the arc, right? Called the arc. This is radius, this is the arc. Arc is the name. Arc length is the distance, the length of this curved line. Arc length is the length. This shape is called the arc. Okay, right. Now, then I can connect the point A to B like this. Connect the line A to B. So the area bounded by this straight line AB and the arc AB or ACB is called the segment. The segment is the whole part, the area. The area is called the segment. Just like here, the area here is called the sector, right? Sector. This area here is called the segment. And you look at this one, right? So here I have shaded the segment in yellow color. The yellow color part is called the segment. And this segment is bounded by two lines. One straight line at the top, and that straight line is called a chord. And a curved line at the bottom, and that curved line is called a segment. Now, if you want to find the perimeter of the segment, you have to add the straight line and the curve. The length of these two lines add together is the perimeter of the segment. So far, okay or not? Do you know what is a segment? What is a chord? What is the arc?
Yes, teacher.
Okay, understand, right? Understand. Okay, right. So this curved line called the arc, if you want to find this curved line called the arc, no problem. The formula is given, S equals to r theta. So this line is called S. You can find, no problem. The problem is this straight line here, the straight line AB, right? So we come back to this straight line AB. This AB comes from this triangle AOB. This triangle AOB. Now this triangle AOB is inscribed inside the circle. The triangle AOB is inscribed inside the circle, right? So it's whole thing is inside. Now if it is inside, we know that the length here is the radius. The other length also is the radius. And normally the angle subtended at the center by the arc is called theta. So these are the three things that we know about this triangle, which is part of the sector. This triangle is an isosceles triangle. Isosceles triangle means the two sides are the same. Why is it the two sides are the same? Because the two sides, they are the radius. They are the radius. So if I want to find this length AB, and this length is known, the angle is known, we can use the cosine rule to find the length AB. Can you still remember cosine rule? Cosine rule. Cosine rule means what? A square equals to B square plus C square minus 2BC cos A. Can you remember this formula? Did you learn this in Form 4? Go or not? Yes, you learned this in Form 4, right? So, Li Yin said you learned this in Form 4. Ang Li Wen also say got learn in Form 4. Okay. Now, if you don't, if you don't remember, then you know when you are small that time, you play the chi chi chong, jump, jump, jump like that, jump. Huh? So this is how you are going to jump. Huh? This is how you're going to jump. This is how you're going to jump. Now this line, and this angle at the center is called the included angle because these two sides is known and this angle is between the two sides. It is bounded by the two sides that is known. So the angle at the center there is the included angle. Now once you see two sides and the included angle, you have to use cosine rule. Now if you see the two sides here and this angle you don't know, and you know the angle at the bottom there, cannot use cosine rule. You have to use the sine rule, right? If it is this type of triangle, two sides known and the angle at the center is known, then you use cosine rule. If you have two given sides, angle at the center don't know, but angle at the bottom you know, use sine rule. So you're going to use the cosine rule. Cosine rule says that AB square, this one square, equals to this square plus this square minus 2BC cos of the angle at the center. So it's like playing chi chi chong. You know, play chi chi chong like that. I don't know whether you play that in the from when you are in primary school or not. Now, if you want to play this type of thing, how I show you how to play. I don't have any triangle with me. Let's say we have this one. Okay. I say this is the triangle. This is the triangle. Huh? So I fold the paper here. So this is the triangle here. This is the triangle. Look at this triangle here. So how to use this formula? You start from here. Start from here. Then you say AB square equals to R square plus R square minus 2R times R cos theta. You see how you jump? Chip, chop. So the jump at the center. You know the game where you jump, hop, hop, hop like that. I don't know in English they call what, hop, don't know what. Little girls, they like to play, right? Okay, right. So that's how we're going to use the cosine rule. Hmm? So we apply cosine rule to this triangle here. AB square is r square plus r square minus 2r times r cos of the angle at the center. So this is it, right? This is it. And you try to find the square root, square root this side, square root this side. So it's the square root of r square plus r square is 2r square lah. 2 times r also 2r square lah. So finally this length AB here is square root of 2r square minus 2r square cos theta. Well, this is, if you don't know cosine rule, then this one may be a bit complicated. So we don't want to use cosine rule, can or not? Can, right? So the second method will be like this. Because this is an isosceles triangle, I split the isosceles triangle into two equal parts by using the line OM. From O to M, you cut the triangle into two different triangles, right? Two different triangles. So when you cut, the angle here becomes what? Half theta, and this is right angle triangle. This is right angle triangle. Okay, so you consider this triangle on the right hand side, OMB. Now this MB divided by R is sine half theta. Okay, I type here. No lah, don't type here. I type here. I type over here. Right? I type over here. Okay. I type here. You consider that right angle triangle MB divided by the hypotenuse OB equals to sine half theta. Okay, so you consider this triangle. So MB is the opposite divided by the hypotenuse OB, right? MB divided by OB is sine half theta. Sine half theta, like that, right? So what you get? MB equals to OB sine half theta. Okay, so when you move the OB here, you get MB equals to OB sine half theta. Okay, so but you don't want to find MB, you want to find AB. This because AB is part of the perimeter. You want to find AB. So what is this AB? AB is 2MB. So it is 2. This one is actually MB is actually this one. It's actually R sine half theta. Okay, it's R sine half theta. So when you want AB you just multiply by 2. Okay, AB is 2MB, right? 2MB. So it's 2R sine half theta. So if you don't know the cosine rule, you want to find AM and AB, can, because in form 1, form 3, in form 3 you have learned this trigonometric ratio, opposite over hypotenuse. Hypotenuse is your radius r. So any question using trying to find this line, this straight line AB. Can find or not the straight line AB here? Using cosine rule or using the this one, using the trigonometric ratio. Any question on this? Yes or no?
No.
No question. Okay, no question. Then if you want to find the next one, coming back to this yellow thing, the yellow thing here is the segment. If you want to find the perimeter of segment, you use AB plus this curved line. This curved line is what? This curved line is the arc length RS. So perimeter is RS plus the straight line, plus this straight line. 2R sine half theta. Can follow or not? Can, huh? Okay, continue here. So we're going to perimeter of the segment, perimeter of the shaded area. Okay, so I copied two questions from the textbook, right? You see the picture on the two diagram there, they actually cut from the textbook, right? Okay, right. So we look at this example here. Find the perimeter of the shaded area. The shaded area here is the green color. The white color is not the shaded area. So if you want to find the perimeter of this green color, you have to find this arc length PQ, the red color arc length PQ, plus the straight line, which is blue color, the blue color PQ. And you add the two of them together, you can find the perimeter of the segment PQ. The green color is a segment, so you find the perimeter of the segment PQ. Okay, now if you want to find the arc length, you want to find the perimeter, whatever it is, you need to know the angle subtended at the center, which is theta. Do you know theta? Don't know theta. So if you don't know theta, you have to find theta first. Then only find the arc length. Then only find the straight line, the chord PQ. That one is called the chord. Okay. So now we proceed. Cannot straight away find the perimeter. You have to find this angle first. How to find the angle? You use this formula. S equals to r theta. How much is the S? 14. How much is the R? 7. Theta? Don't know. So from here we can find theta equals to 2 radian. 2 radian. Now then Li Ying will ask, hey, can I leave the answer in 2 radian? Now if you want to get the marks until this part, can. You just leave 2 radian is correct. The angle is 2 radian. But because the following part, you need to make use of this angle in degree. So when you find the answer in radian, try to convert it into degree also, so that you have two units for the same angle. You have two different version of the same angle. Okay, right. So although the question didn't ask you to convert to degree, try to convert to degree, right? Li Ying, can, right. So answer theta is 2 radian. Another answer, 2 times 180 divided by pi, and the answer is 144.59 degrees. Then the question you may ask, teacher, need to convert to minute or not? This one I'm very confident. No need to convert to minute unless the question asks. If not, no need. This is easier to apply, easier to type into the calculator. Okay or not? Okay or not? Who is that?
Okay, teacher.
Ken. Okay. So Li Yin said can. Now, one more time, if you get the answer in radian, convert to degree, it will be useful. But need to go to minute or not? No need. Just leave it in decimal place. Okay, so now I have the angle already. So I want to find the perimeter. Perimeter of this green color is the arc PQ plus the chord PQ. Arc PQ is this curved line, which is r theta. So r is 7, 2. You don't want to calculate also can, because the arc is already given 14. So you can straight away put down 14. Okay, next, I want to find this straight line, the chord PQ. Chord PQ, 2r sine half theta. So 2r, right? 2r, r is 7. Sine half theta. Half theta is 144.59, but you have to divide by 2 because we split the isosceles triangle into two right angle triangle. So you have to divide by 2. Now another thing is the angle inside this trigonometric function. Don't put in radian, because your calculator, already set in degree mode. So your calculator can only accept degree. So here, this one, please use degree, don't use radian. Otherwise, you get all the wrong answer. Any question regarding this one? This here? Sine, you have to use degree. R theta, you have to use radian. Two different units in the same line. Okay or not okay?
Teacher,
Yes.
for
Yes.
the first example, just now I used the calculator. I get 144.58. Can for the answer.
Uh you round off lah. Round off to.
Yeah, teacher already round off because I got 114.576 and then I round off become
I check and see.
114.58.
I check and see. 180 divided by pi. 180 divided by pi times 2. My calculator is 114.59. Can see Can see
Can
can
teacher.
my calculator something wrong. What for 144.59. Okay, right. So don't worry about one decimal place though, because in the exam they give you allowance the last decimal place plus 1 minus 1. Okay or not? So don't worry about the
Teacher, for the answer you write wrong already. It's 114, not 144.
114. Sorry, 114. Is it 59 or not like that?
Yeah,
One
I think.
one one four
Yeah,
five nine. 11459.
yeah.
Okay, so here 114, very simple. 11459. So this one is 50 57. 57. Is it 57?